Hi, my name is Kwan. I'm currently an assistant professor at the School of Material Science and Engineering, and it's a privilege to actually sit over here talking to you, as I was also a former student with the school. I'm currently the course coordinator for MS 1017, Introduction to Material Science. So in this course, our freshman students would be introduced to the world of material science and engineering by borrowing concepts from very many different kinds of discipline and then putting them together. Over in this class, students would learn about materials at a very fundamental level, down to the atoms and subatomic length scales. And follow up, we will start to build up these atoms to these larger building block superstructures, which we call as crystal lattices, and how these crystal lattices eventually will translate to the different materials properties that we have seen in all different kinds of applications. So for example, we like to say metals are ductile, metals are strong. In this class, this is exactly how our students will learn why they have this behavior and how we can further modify their behaviors and making it into the eventual applications that we see in everyday life. Okay, so let me give you an example of how this class enhances your understanding of everyday life. Now, imagine that you head to your kitchen, you pick up a piece of aluminum foil, which is a wonder material because you can use this to cover and bake your favorite barbecue wings, and you can do a lot of very interesting projects, homemade projects with aluminum foil, right? They are soft, they are ductile, and they are shiny. But now imagine that you take many of these foils and stack them up together. The properties have now changed. The material itself is no longer as ductile, but it's even stronger. And now this is actually used to build up the bodies of your latest smartphone gadgets, which give you the confidence of, in case you fall on the ground, your phone is still surviving and you still can use and surf your latest TikToks or even Instagram videos. Now in this class, we'll try to be as interactive as possible. So beyond the typical two-way traffic, when we encourage students to interact with us and learn from each other, we also want to bring in real-life samples to relate as closely to what you're learning from the books and notes, from 3D models to real-life examples of, for example, in this laptop. And of course, another component that have been introduced in this class is real-time experiments, where students will get to work with different metals and understand how they are deforming in real time using our tensile test instruments. So in MS 1018, we learn a new realm of different properties of materials. For example, in electrical properties, you learn how to design materials for the fastest transistors in CPUs and GPUs. For magnetic properties, we learn how to design materials to increase the storage of magnetic hard disk. In thermal properties, you learn how to design fabrics that is cooling as well as keep your warmth during winter. And of course, with optical properties, we can even apply these concepts in real life animals, for example, the wings of the butterflies. So I hope to see you soon.